This lesson is on helping AI make decisions. In this course, you will explore how to guide and influence AI systems to make effective decisions using various techniques and strategies, from setting up the right inputs to designing decision-making frameworks. This lesson will help you understand how to optimize AI for better outcomes. AI decision-making involves analyzing data, identifying patterns, and choosing results based on predefined criteria or learned behaviors. There are different approaches to guiding AI decision making, including rule-based, machine learning models, and reinforcement learning. In a rule-based system, decisions are made based on a set of predefined rules. This approach is often used in simpler AI applications where the rules can be clearly defined. If you look at this example, you will notice the AI uses simple rules to determine the appropriate response to customer queries. If you run this, you'll see you can request a refund by filling out the refund form on our website. Shipping details are available in your order confirmation email. You can modify this code according to your needs. Now let's talk about machine learning models. Machine learning models make decisions based on patterns that are learned from the data. Training a model involves feeding it a dataset, allowing it to learn from the examples, and then using the trained model to make predictions or decisions. Let's see an example that has predicting house prices. So you import these two libraries, which are linear regression and NumPy. Then this is a sample data. The values of x and y are stored in NP arrays. And then you train the model using the linear regression model, and then you print the predicted price. If you run this, you'll notice that the regression model predicts house prices based on the square footage, demonstrating how machine learning can guide decision making based on historical data. It says predicted price for 1800 square foot is $280,000. Moving on to reinforcement learning. Reinforcement learning, or RL, involves training an AI agent to make decisions by rewarding it for desirable actions and penalizing it for undesirable ones. Over time, the agent learns to maximize its cumulative reward. Now let's look at an example. So firstly, we import the NumPy array, and then we define the environment. The states and the actions are given certain values. They are stored in an NP array. Then there is a queue table that has lengths of states and length of actions. Then we train the parameters using alpha gamma values. The episode is set to 1000, and then we used a for loop with conditional statements if, and then we print the output. If you run this, you'll see that reinforcement agent learns the optimal actions to maximize rewards over time through exploration and exploitation. So the queue table after training are these values. Moving on to guiding AI decision making with constraints and objectives. To ensure AI makes decisions that align with your goals, you can define constraints and objectives. This approach helps the AI to focus on what's more important and avoid undesirable outcomes. Let's look at a scheduled meetings example. Firstly, we imported datetime from datetime library. Then we defined a function named schedule meetings. It takes in preferred time and busy slots as input. And then we defined the slot times. We used a for loop and conditional statements. And then we printed the results. So in this scheduling example, the AI considers constrained busy slots and objectives that were preferred time to find an available slot for the meeting. So it says scheduled meeting time is 2024 8 10 and the time is 9. It's essential to evaluate the decisions made by AI systems to ensure they meet your expectations and performance criteria. You can use matrices such as accuracy, precision, recall, and user feedback to assess the effectiveness of the AI's decision. Helping AI make decisions involves understanding various decision-making approaches, from rule-based systems to advanced machine learning and reinforcement learning. By defining constraints, objectives, and evaluating performance, you can guide the AI to make decisions that align with your goals and requirements. With these techniques, you are equipped to develop AI systems that are both effective and reliable.